everyone, I am Suhaana and today we will be learning about black holes. A black hole is a dead giant star. It can be as small as a dot and can expand to be the size of many solar systems. This amazing object has such a strong gravitational force that it sucks everything that comes in its way. Even the fastest thing in the universe, light, can't escape it. The gravity is so strong because the matter has been squeezed into a tiny area. Stars are born from dust clouds known as stellar nebulas. The stellar nebula becomes an average star or a massive star depending on its mass. If its mass is more than 8 solar masses, it becomes a massive star. However, if its mass is less than 8 solar masses, it becomes an average star. The nebula can proceed in two different directions, but today we will only speak of the second direction, through the massive star. When the high mass star runs out of fuel, which is hydrogen, the core becomes hotter and smaller, resulting in a red supergiant. This red giant lives for a few billion years. When the hydrogen is gone, a new fuel, which is helium, is created. Eventually, the helium also runs out, making the star pulsate. The core of the star continues shrinking, while the outer layer keeps growing bigger and bigger. When all the fuel runs out, the star bursts into a huge explosion, known as the supernova. Did you know that the supernova explosion is even brighter than the galaxy it's in? It is even brighter than the sun can shine in its entire lifetime. After the explosion, the outer layer bursts, but the core is still left behind. The remaining core has two choices left. If the core is between 1.4 and 3 solar masses, it becomes a neutron star. However, if the mass of the core is more than 3 solar masses, this becomes a black hole. There are 4 types of black holes: stellar black holes, supermassive black holes, intermediate black holes, and miniature black holes. Stellar black holes can fit as much as 3 suns into the space of a single city. Scientists believe that there are over 10 million stellar black holes in the Milky Way alone. Supermassive black holes are found at the center of each galaxy. They are 30 billion times more massive than our sun. The supermassive black hole at the center of the Milky Way is called Sagittarius A. Scientists still don't have enough information about the intermediate black holes, as there has been only one intermediate black hole recorded in history. We still don't have enough information on miniature black holes, but we know that they have the mass of Mount Everest. Parts of a black hole. All of the black holes have 3 parts: singularity, inner event horizon, and outer event horizon. If you're in the outer event horizon of the black hole, you can still escape. But if you're in the inner event horizon of the black hole, you will get sucked in no matter what. The singularity is the center of the black hole, or the dead star. This is the point of no return. You must be wondering, can a black hole live forever? Well, listen carefully if you want to know. A black hole evaporates over time. This happens when a black hole stops eating. This process is known as Hawking radiation. When the black hole is the size of an asteroid, it is at room temperature. When it shrinks further to the size of a mountain, it is as hot as a sun. And in the last second of its life, it bursts with the power of 1,000,000 nuclear bombs. But this process takes a few googol years. Can you take a picture of the black hole when the background and the object are of the same color? Black holes are very far away. As a result, we will need a telescope as big as Earth to take a picture of black holes, which is not possible. So, scientists have figured out another way to do this. Instead of one giant telescope, scientists have split up 8 different telescopes around the globe. These telescopes together are known as the Event Horizon. With these telescopes, scientists continuously take pictures of a single black hole throughout the year. This way, they can choose all the angles and put them together as puzzle pieces at the end. This forms a picture of a black hole. This process has only been done once before in 2017. It took a few weeks to take the pictures and about 2 years to put them together. This process is known as interferometry. Given above is the only picture taken of a black hole till date. It was taken on 10th April, Wednesday 2019. It is in the middle of the galaxy Messier 87, which is 55 million light years away. This is 6.5 billion times the size of our sun. The light which you can see is called the accretion disk. This disk is created when the black hole has just eaten a star. The hole in the center of the black hole is 25 billion miles long. Let's learn some fun facts. Some think that black holes are like cosmic vacuums that suck everything which comes in its way, when in fact, black holes are like any other object in space, just with a very, very strong gravitational field. If you replace the sun for a black hole with equal size and mass, Earth would not get sucked in but would continue revolving around it. But we would freeze to death. Some scientists believe that supermassive black holes anchor galaxies together, holding them together in space and time. Time slows down inside a black hole. Scientists have found a new object in space, a white hole. According to their theory, the white hole doesn't suck the matter but pushes it away. The existence of white holes has not been confirmed. There's so many black holes in the universe that it is impossible to count, but they're estimated to be over 100 billion of them. When two black holes collide, they form a giant black hole. Black holes have this incredible ability to literally stretch your legs into a long spaghetti-like strand. This is because one side of the black hole has a stronger gravitational pull than the other. Appropriately, this phenomenon is called spaghettification. The end of the universe. The universe started with the Big Bang. When the galaxies were created, the dark matter and gravity started working at the same time. For example, when you study any two galaxies, the gravity between them is pulling them closer, while the dark matter is pulling them apart. If the dark matter wins this war, then the galaxies will continue drifting apart. Soon, the minor parts of the galaxies will also start drifting, including the atoms. This will result in a cold and dark area throughout the universe. This theory is known as the Big Freeze. There is another possibility known as the Big Crunch. If the gravity wins this war, then everything will start coming back together and bang into each other, making a replica of the Big Bang. Some scientists believe that this goes on and again, and every time it happens, we lose the history of the previous universe. Lastly, if the dark matter pulls and rips up all the gravity in the universe, All the parts of the universe and everything inside it will rip apart, just like the gravity. This scenario is known as the Big Rip. But most scientists believe that we are heading towards the Big Freeze.
Oh no!